Okay, picture this. A spacecraft,
Yeah.
not just orbiting the sun, but actually diving into its atmosphere.
Wow.
It sounds kind of like science fiction, right?
It does.
But that's exactly what the Parker Solar Probe is up to.
Yeah.
And it's sending back data that's basically changing everything we thought we knew about our very own star.
Right.
Welcome to Cosmos in a Pod Space and Astronomy series.
Yes.
So we've all heard of the Parker Solar Probe, but why is this mission such a big deal?
Well, it's humanity's first mission to really touch the sun. I mean, think about it. We send probes to other planets, but the sun, that's a whole other ball game.
Right.
The heat, the radiation, the sheer speed the probe needs to achieve.
It's mind-boggling.
It's mind-boggling.
Yeah, over 700,000 kilometers per hour. That's what I read.
Wow.
Faster than anything we've ever built.
Yeah.
But how does it not melt?
Well, that's where the real genius comes in. The Parker Solar Probe has what's called a thermal protection system, or TPS for short.
Okay.
So imagine a shield made of like these cutting-edge carbon composite materials, so advanced that it can withstand temperatures over 3,370 degrees Celsius.
Wow. So it's basically like wearing a super suit.
Right.
But even with that,
Right.
what are the scientists actually hoping to achieve? It's not just like a joyride, is it?
Oh, definitely not. The mission has three main goals.
Okay.
The first is to study the sun's corona, that outer atmosphere that we see during eclipses. And specifically, they want to understand how the solar wind is accelerated.
So like figuring out the source of the wind, why is that so important?
Because that solar wind, that stream of charged particles, it has a huge impact on Earth.
Right.
Like, it can disrupt satellites, mess with power grids, even affect astronauts in space.
Okay, so understanding it helps us like predict and maybe even prevent those disruptions?
Yeah, exactly.
So that's goal number one. What's next?
So the second goal is to tackle a mystery that's baffled scientists for ages.
Okay.
Why is the sun's corona millions of degrees hotter than the sun's actual surface?
Yeah, it's like the air around a fire being hotter than the flames themselves, right?
Yeah, exactly.
So that doesn't make sense. What's the leading theory?
Well, there are a few,
Yeah.
But the Parker Solar Probe is providing evidence that these things called Alpha waves might be the key.
Okay.
So they're like ripples of energy that travel along the sun's magnetic field lines.
Okay.
And they might be carrying energy from the sun's interior out to the corona where it kind of dissipates as heat.
So they're like tiny little energy surfers riding the magnetic waves and depositing heat.
That's a great way to put it.
Fascinating.
Yeah.
All right, so we've got solar wind acceleration and the corona's crazy heat.
Right.
What's the third big goal?
It's all about improving space weather prediction. The more we understand the sun, the better we can forecast things like solar flares and coronal mass ejections.
Okay.
These events can have a huge impact on our technology and infrastructure here on Earth.
So this mission is not just about, like, scientific curiosity.
No.
It's about protecting our planet.
Exactly. The data the probe is collecting is helping scientists develop better models to predict and prepare for those space weather events. It's like having, a more accurate weather forecast, but for space.
Okay, so now I understand why this mission is so important. But how on Earth, or rather, how in space, does the Parker Solar Probe even get close to the sun? It's not like we could just point a rocket at it and blast off.
No, it's way more complicated than that. It's actually an incredible feat of orbital mechanics.
Okay.
So to get the probe close to the sun, they use what are called gravity assists.
Gravity assists. I've heard that term before.
Yeah.
Don't they use those for other missions too?
Right. It's a technique where they use the gravitational pull of a planet to alter a spacecraft's trajectory and speed.
Okay.
And in this case, the Parker Solar Probe uses Venus.
Okay.
Does these flybys, almost like slingshot maneuvers, to get closer and closer to the sun with each orbit.
So Venus is like a cosmic pit stop, giving the probe a speed boost.
Right.
Pretty clever.
Yeah.
How many times does it swing by Venus?
The probe will complete 24 orbits around the sun during its mission.
Wow.
And each of those orbits gets fine-tuned by those Venus flybys, taking it closer each time.
That's amazing.
Yeah.
And I bet the data gets more and more interesting with each closer pass, huh?
Absolutely. In fact, in 2021, the probe achieved a monumental milestone.
Okay.
It became the first spacecraft to actually enter the sun's corona. It touched the sun.
Whoa, hold on. It actually flew into the sun's atmosphere. Isn't that incredibly dangerous?
It is,
Yeah.
which is why that TPS is so
Yeah.
crucial. You know, it's designed to take the brunt of the heat and radiation,
Yeah.
keeping the delicate instruments safe inside.
Oh.
And remember, the probe is also incredibly smart.
Mm-hmm.
It uses artificial intelligence to adjust its position and make sure the heat shield is always facing the sun.
So it's like a self-driving spacecraft
Yeah.
navigating the most extreme environment imaginable.
Right.
Amazing.
It really is.
Yeah.
And the discoveries it's sending back are just as incredible.
Okay, I'm dying to hear about those discoveries.
Yeah.
What are some of the things we're learning about the sun thanks to the Parker Solar Probe?
Well, one of the most fascinating findings is the discovery of these things called switchbacks.
Switchbacks, what are those?
Imagine driving down a road and suddenly encountering a series of sharp hairpin turns.
Okay.
That's kind of what switchbacks are like.
Yeah.
But in the sun's magnetic field,
Okay.
there's sudden dramatic reversals in the field's direction.
So the sun's magnetic field is more like a roller coaster than a straight line. Okay, what do these switchbacks have to do with anything?
Scientists believe they play a significant role in accelerating the solar wind.
Okay.
It's like they give those charged particles an extra kick,
Right.
propelling them outward at incredible speeds.
Wow, that's wild. So the probe is helping us understand how the sun's magnetic field shapes the solar wind.
Exactly.
What else have we learned?
We're getting a much clearer picture of the sun's magnetic field in general.
Okay.
You know, it's not this smooth, static thing we used to imagine. It's constantly changing
Uh-huh.
with these swirling, turbulent structures that influence the solar wind
Right.
and contribute to the sun's overall activity.
So it's more like a wild, untamed beast
Right.
than a well-behaved pet.
Exactly. And the Parker Solar Probe is giving us a front row seat to this wild beast's behavior, which is key to understanding space weather and its impact on Earth.
Okay, so switchbacks, turbulent magnetic fields. What else has the probe revealed?
Well, remember that mystery about the corona being so much hotter than the sun's surface?
Yeah.
Well, the Parker Solar Probe has provided some pretty compelling evidence to support the theory that alpha waves are responsible for that extreme heating.
Those little energy surfers we talked
The
about.
very same.
Okay.
It seems they transport energy from the sun's interior out to the corona where it dissipates, causing the dramatic temperature increase.
So the Parker Solar Probe is essentially confirming a long-held theory.
It is.
Wow.
And that's huge. It's like finding the missing piece of a puzzle that scientists have been grappling with for decades.
This is all so fascinating.
Yeah.
But even with all these amazing discoveries, I have a feeling there's still so much more to learn about the sun, right?
Oh, absolutely.
Yeah.
We're only scratching the surface.
Right.
The Parker Solar Probe is raising just as many questions as it's answering.
Right.
And that's what makes this mission so exciting.
Okay, I'm all ears. What are some of the mysteries that still puzzle scientists? What are we still trying to figure out?
Well, one of the biggest puzzles is still the corona's extreme heat.
Right.
You know, we've got these alpha waves
Yeah.
as a possible explanation, but the exact mechanisms behind how they heat the corona to millions of degrees,
Right.
that's still a big unknown.
So it's like we know the suspects are there,
Right.
but we haven't cracked the case yet.
Exactly. And then there's the solar wind. You know, we've learned about those switchbacks and how they give the wind an extra kick,
Right.
but we don't fully understand
Yeah.
how those switchbacks form in the first place.
Right.
What triggers them?
Right.
How do they interact with the sun's magnetic field?
It's like we've opened one door
Yeah.
only to find a whole hallway of other mysteries.
Precisely.
Yeah.
And the Parker Solar Probe is giving us the tools to explore those mysteries in ways we never could before.
It's mind-blowing to think that we're now able to study the sun up close like this.
I know. It's amazing.
It's changing everything we thought we knew about our star.
It really is a game changer.
Yeah.
And speaking of changing things, one of the most important aspects of this mission is its impact on space weather forecasting.
We've talked about how the probe's data is helping us better predict solar storms,
Yeah.
but I'd love to dig a little deeper.
Yeah.
Can you walk us through how that actually works?
Okay, so imagine
Yeah.
trying to predict a hurricane.
Okay.
You need data on wind speeds,
Right.
air pressure,
Mm-hmm.
temperature,
Yeah.
All those factors help meteorologists
Right.
create those hurricane paths
Yeah.
we see on the news.
Right. Right.
Space weather is similar.
Right.
We need information about the sun's activity to predict those solar storms.
So the Parker Solar Probe is essentially acting like a weather buoy, but for space.
Exactly. By measuring things,
Yeah.
like the solar wind speed, density, and composition,
Okay.
and by closely monitoring the sun's magnetic field,
Yeah.
scientists can start to see patterns,
Right.
understand the triggers, and
Right.
build models to predict those solar flares and coronal mass ejections.
It's like we're finally getting a glimpse into the sun's inner workings. And that knowledge is crucial for protecting our technology here on Earth.
It is. Think about all the satellites we rely on for communication, navigation, even weather forecasting here on Earth.
Right.
A major solar storm could disrupt or even destroy those satellites, causing havoc.
It's a stark reminder of how dependent we are on technology. And how vulnerable that technology is to the whims of the sun.
It's true. And that's why missions like the Parker Solar Probe are so crucial. The more we understand the sun, the better we can protect ourselves from its potentially destructive outbursts.
So this mission isn't just about expanding scientific knowledge.
No.
It's about safeguarding our planet and our way of life.
Absolutely. It's a testament to the fact that fundamental research, even research that seems far removed from our daily lives, can have profound and practical implications for humanity.
Okay, I'm even more impressed with this mission now.
Yeah.
But I can't help but wonder, with a mission this complex, this daring, there must have been some serious challenges along the way.
Well, without a doubt. Anytime you're pushing the boundaries of exploration like this, you're bound to encounter some hurdles.
What were some of the biggest challenges the mission team had to overcome? I mean, we're talking about sending a probe to essentially fly through fire.
That's a great way to put it. The heat and radiation were obviously major concerns. Designing a spacecraft that could withstand those conditions for years on end required some truly groundbreaking engineering.
I know we talked about the heat shield, but what other challenges did they face?
Well, think about the intense gravity near the sun that posed a huge challenge for navigation. The slightest miscalculation could have sent the probe spiraling into the sun. It took incredible precision and some very clever orbital mechanics to get it into the right position and keep it there.
It sounds like a delicate balancing act between physics and engineering.
It really was. And then there were the everyday challenges of space exploration, the risk of equipment malfunctions, communication glitches, the sheer distance involved. All of those factors added to the complexity of the mission.
It's amazing to think about the dedication and ingenuity it took to make this mission a reality.
It really is a testament to human ingenuity and perseverance. And it's important to remember that this wasn't the work of just a few individuals. It took a massive collaborative effort involving hundreds of scientists, engineers, technicians, and support staff from around the world.
It's a global effort,
Yes.
united by a common goal to understand our sun and unlock its secrets.
Exactly. And that collaborative spirit is one of the most inspiring aspects of this mission. It shows what we can achieve when we pool our resources, our talents, and our passion for exploration.
Okay, I have to ask.
Sure.
What's it actually like for the scientists and engineers involved in this mission? I mean, to be part of something this groundbreaking.
You're right.
This historic.
I can only imagine it's an incredible mix of emotions.
The
years of hard work, the anticipation, the moments of pure joy when they receive that data. And realize they're seeing things no one has ever seen before.
It's like they're explorers charting a new world. But this world is our very own star.
That's a great analogy, and I'm sure there are also moments of intense focus, problem solving, even a bit of nail biting, as they wait for the probe to send back its precious data.
It's a high-stakes endeavor.
It is.
But the rewards are immense. Not just for the scientific community, but for humanity as a whole.
Absolutely. We're learning so much about the sun, and that knowledge is directly applicable to our lives here on Earth. From protecting our technology to understanding our planet's climate.
It's a reminder that the pursuit of knowledge is never in vain.
It's not.
It always leads to new insights, new innovations. and a deeper appreciation for the universe we inhabit.
I couldn't have said it better myself.
Yeah.
The Parker Solar Probe is a shining example of that principle in action.
Okay, I know we've been talking a lot about the science and the technology,
Yeah.
but I can't help but be struck by the sheer beauty and wonder of this mission.
Oh, absolutely. There's
Mm.
something deeply poetic about this tiny spacecraft
Right.
braving the inferno of the sun's atmosphere
Right.
to reveal its secrets.
It's a reminder of our place in the grand scheme of the cosmos.
Yeah.
We're this tiny species on a tiny planet,
Right.
yet we're capable of sending a probe to touch the sun.
I know.
It's mind-boggling.
It really puts things in perspective, doesn't it?
It does, yeah.
And it speaks to the boundless curiosity and ingenuity of humankind.
Okay, before we get too philosophical,
Okay.
I have to ask.
Okay.
What's next for the Parker Solar Probe?
Hmm.
What does the future hold for this incredible mission?
Well, the mission is currently scheduled to continue until 2025.
Okay.
But there's always the possibility of extending it if the spacecraft remains healthy
Right.
and continues to provide valuable data.
And what about beyond 2025? Are there any plans for future missions
Oh, yeah.
to build on the Parker Solar Probe's discoveries?
Absolutely. The Parker Solar Probe is paving the way for a whole new generation of solar missions.
Can you give us a sneak peek
Sure.
at what some of those future missions might look like?
Well, one idea that's been floated is a mission to orbit the sun's poles.
Orbit the poles. Wow, that would be a completely new perspective.
It would.
We've only ever observed the sun from its equatorial plane.
Exactly. A polar orbiter would give us a unique view of the sun's magnetic field and solar wind,
Right.
potentially revealing even more about how those processes work.
That sounds incredible. Any other ideas in the works?
Another possibility is a mission to send a probe even closer to the sun. Then the Parker Solar Probe, perhaps even into the sun's chromosphere,
Okay.
the layer just above the photosphere.
That would be a truly daring mission.
It would.
But I imagine the technological challenges would be immense.
They would.
Yeah.
The heat and radiation in the chromosphere
Right.
are even more intense than in the corona.
Yeah.
It would require some serious advances in materials, science, and spacecraft design to even contemplate such a mission.
It sounds like a mission for the future, but it's exciting to think about the possibilities.
It is, and who knows what other groundbreaking discoveries await us
Right.
as we continue to push the boundaries of solar exploration.
It's a thrilling time to be alive
Yeah.
and witnessing these incredible advancements in our understanding of the sun.
I agree. It's a golden age of solar exploration.
Yeah.
And we're just getting started.
Well, I'm completely hooked on the Parker Solar Probe now.
Yeah.
I can't wait to see what other secrets it reveals about our star.
Me too.
But before we wrap up,
Okay.
I'm curious about one more thing. With all the focus on the sun,
Uh-huh.
it's easy to forget that our star is just one of billions in the Milky Way galaxy.
That's true. It's important to remember that the sun, for all its power and importance to us, is just one star among countless others.
So what can we learn from the Parker Solar Probe that might be applicable to other stars? How does this mission fit into the bigger picture of astronomy and our understanding of the universe?
That's a great question.
Yeah.
The sun is our closest star.
Right.
And as such, it's the one we can study in the most detail.
Right.
What we learn about the sun
Yeah.
can be used to understand other stars,
Right.
their life cycles,
Ah.
their magnetic fields,
Right.
their interactions with their planetary systems.
So it's like using the sun as a Rosetta Stone to decode the language of the stars.
Exactly. By understanding the sun,
Yeah.
we gain insights into the fundamental processes
Right.
that drive stars throughout the universe.
Right.
And those insights can inform our search for exoplanets,
Right.
our understanding of galaxy formation, even our theories about the origins of the universe itself.
It's incredible to think that a mission focused on our own sun
I know.
can have such far-reaching implications
Yeah.
for our understanding of the cosmos.
It's a testament to the interconnectedness of everything in the universe.
Right.
Studying one star can shed light on the workings of the entire cosmos.
Okay, that officially blows my mind.
Yeah, it's pretty amazing.
But on that note, I think it's time to start wrapping things up.
Okay.
It's been an incredible journey,
It has.
exploring the Parker Solar Probe and its daring mission to touch the sun.
It has been a fascinating discussion.
Yeah.
I'm always amazed by the ingenuity and determination of the people who make these missions possible.
It's truly inspiring. And it's a reminder that even in the face of immense challenges, humanity's thirst for knowledge and exploration will always push us forward, driving us to reach for the stars.
Well said. The Parker Solar Probe is a beacon of that spirit, and its legacy will undoubtedly inspire generations to come.
I have no doubt about that.
Good.
But before we say goodbye,
Okay.
I want to make sure our listeners know where they can go
Right.
to learn more about this incredible mission.
Huh?
I know I'm definitely going to be digging deeper into this
Oh, me too.
after our conversation. So,
Yeah. Well, a great place to start is NASA's website.
okay.
They have an entire section dedicated to the Parker Solar Probe
Okay.
with mission updates, images, videos,
Right.
and even raw data from the probe.
I bet those images are incredible.
They are.
Seeing the sun's corona up close must be mind-blowing.
It is. They're truly breathtaking.
Yeah.
And if you're looking for a more visual and engaging way to learn about the mission,
Uh-huh.
I highly recommend checking out the Cosmos in a Pod YouTube channel.
Yes. Our team has put together some fantastic
Oh,
videos
they're great.
that bring the Parker Solar Probe mission to life,
They do.
complete with stunning visuals and
Oh.
easy-to-understand explanations.
It's a great way to explore the science and engineering behind this groundbreaking mission.
So whether you prefer reading, watching, or listening,
Yeah,
there's a wealth of information out there
there is.
for anyone who wants to learn more about the Parker Solar Probe.
And I encourage everyone to do so.
Yeah.
It's a story that will ignite your curiosity and leave you with a sense of wonder about the universe we inhabit.
Well, on that note,
Yeah.
I think it's time to wrap up our deep dive into the Parker Solar Probe.
It's been a pleasure exploring this remarkable mission with you.
The pleasure was all mine.
Oh, good.
I've learned so much today,
Me too.
and I'm sure our listeners have too.
Yeah.
The Parker Solar Probe is a testament to human ingenuity,
It is.
our thirst for knowledge, and our enduring fascination with the cosmos.
And as the mission continues, I have no doubt it will continue to reveal even more secrets about our star and inspire future generations of scientists and explorers.
If you enjoyed this deep dive, be sure to follow Cosmos in a Pod for more fascinating explorations of the universe.
Yes.
And don't forget to check out our YouTube channel for stunning visuals and videos related to today's episode.
They're really something.
Until next time, keep looking up
Absolutely.
and keep wondering.
And may your curiosity lead you to even more amazing discoveries.
Yeah, it's a really remarkable mission. And it's not just for like scientists and engineers, you know?
Right.
It's a story that can capture like anyone's imagination, I think.
You're absolutely right.
Yeah.
There's something profoundly humbling and inspiring about this tiny spacecraft venturing closer to the sun than anything we've ever sent before.
It's like a symbol of humanity's drive to explore,
It is.
to push beyond the limits of what we thought was possible.
Exactly.
Yeah. It's a reminder that there's still so much out there to discover, even in our own cosmic backyard.
So much, yeah.
Speaking of discovering, I'm sure our listeners are eager to learn more about the Parker Solar Probe and its findings. Where can they go to dive deeper into this fascinating mission?
Well, a great place to start is NASA's website.
Okay.
They have an entire section dedicated to the Parker Solar Probe with mission updates, images, videos, and even raw data from the probe.
I bet those images are incredible.
They are.
Seeing the sun's corona up close must be mind-blowing.
It is. They're truly breathtaking.
Yeah. And if you're looking for a more visual and engaging way to learn about the mission, I highly recommend checking out the Cosmos in a Pod YouTube channel.
Yes, our team has put together some fantastic videos that bring the Parker Solar Probe mission to life,
Yeah.
complete with stunning visuals and easy-to-understand explanations.
Yeah, it's a great way to explore the science and engineering behind this groundbreaking mission.
It is.
So whether you prefer reading, watching, or listening, there's a wealth of information out there for anyone who wants to learn more about the Parker Solar Probe.
And I encourage everyone to do so. It's a story that will ignite your curiosity and leave you with a sense of wonder about the universe we inhabit.
Well, on that note, I think it's time to wrap up our deep dive into the Parker Solar Probe.
It's been a pleasure exploring this remarkable mission with you.
Absolutely, the pleasure was all mine.
Good, I'm glad.
I've learned so much today, and I'm sure our listeners have too. The Parker Solar Probe is a testament to human ingenuity, our thirst for knowledge, and our enduring fascination with the cosmos.
And as the mission continues, I have no doubt it will continue to reveal even more secrets about our star and inspire future generations of scientists and explorers.
Well, if you enjoyed this deep dive, be sure to follow Cosmos in a Pod for more fascinating explorations of the universe.
Yes.
And don't forget to check out our YouTube channel for stunning visuals and videos related to today's episode.
They're really something.
Until next time, keep looking up and keep wondering.
And may your curiosity lead you to even more amazing discoveries.